Hi, so this video is really inspired by this idea of squishy circuits, which apparently the original person that came up with this idea is Anne Marie Thomas. She's a professor at the University of St. Thomas. You can actually buy squishy circuit kits. You don't really need that, though, to do a lot of the stuff that I'm going to do here. You can do this with a variety of parts. And I'm going to use Play-Doh. Now, some of the things that we're going to look at, terms that we're going to come up with demonstrations for and explore: open circuit, closed circuit, the concept of resistance, a parallel circuit, series circuit, insulator, and conductor. And again, we're going to do that by really, in my case, messing around with Play-Doh and some insulating materials. All right, so let's get to it. So we have here, again, just a 9-volt battery. I do want to kind of mention something real quick before we get into this. It is a good thing. So this is stranded wire. It's like in the interior here, this is like a rope. You can see these separating out. For the kind of work, though, that we're doing here, though, a lot of the time, is that you really want something solid. So notice that this says consolidated on it. So when I cut this off, I just get like a solid piece there that for my purposes are, if I'm working with a breadboard or working with like things like Play-Doh, it's a little bit easier to deal with. I'm not saying that you can't deal with the stranded, but it's just better. I recommend the solid wire. So shout out there for solid wire for this kind of work. Okay, at any rate, so here we go, 9-volt battery. I've got these female to male jumper cables here. I have the black one for the negative, the red one for the positive. And what I have here I have a bunch of small cans of Play-Doh, and I have 2 little green balls of Play-Doh already rolled up here. So I'm gonna, these are conductive, I think, because there's the salt content of Play-Doh. All right, so at any rate, I'm gonna look at this. I'm gonna plug this in here, and I'm plugging this in here. So, right now, nothing is happening. We don't even have any kind of interesting output device. So I'm gonna get my LED out. So, and then as we know, the positive side, the cathode side, this one is the longer one, so that's going to be here. And actually, well, I could just switch these, it doesn't matter. But it is important, right, that my current's going to flow from positive through the LED to the negative. So it should be that if this Play-Doh is in fact conductive, that if I just stick this in here, so my positive end is in this one, and my negative end is in here, and nothing happens. So why not? Well, it turns out that the end of my jumper cable has slipped out. So if you look over here, see, that isn't going to work. Okay, so let me go ahead and plug that in, and this should light up at that point. And there we go. So now, good, we have that lit. That's great. That's kind of the LED is confusing the autofocus a little bit, but all right, so we see that, and this is just a closed circuit, right? Because why? So because I've got my positive, and this is my current's going to run this way, up like through the LED, through the other side, and out now to the negative and back to the battery. So the circuit is closed. Okay, good. All right. It is a little bit dimmer. I think it's a little hard to tell from the in the video, but then when I hooked it up directly, because it has to deal with the Play-Doh. Jump ahead a little bit. I've taken a second and I've made 2 kind of more elongated pieces of Play-Doh, and again, so I've got my my positive here, so my current's going to flow this way through the red, my positive, and then like once I put some kind of connector here, it's going to go, my electricity is going to go across here, and going to go through my negative, and that's going to close my circuit. So, okay, so let's take an LED, and remember the positive side is going to go with a red. That's the longer side. And we should see this light up. Switch this out a little bit. And it does, which is reassuring. And now, I can go ahead and just stick some more LEDs in here. And I've got a positive to a negative. And I'm going to do 3 of them. And I think I have that the right way. Looks like I don't have it the right way. Whoops. Okay, whoop, it's barely touching. There we go. Okay, so there we go. And these are, okay, I think you can see that. And it's like hard to, whoops, it's hard to tell from there. But I've got the longer end stuck in the Play-Doh on both. So this is actually a parallel circuit, the way this is. If I pull any of these lights out, the other lights will still go. That's a hallmark of a parallel circuit. And I guess just another thing, like as far as like just a basic rule of electricity goes, is if I shove these 2 pieces of Play-Doh together, I should see these LEDs go out. And I do. Now, the reason is because that electricity wants to take the easiest path there. And the easiest path is not through the LED, it's through the Play-Doh. So that's another term I didn't even have on my list, which, you know, I think this is a short circuit if I didn't want it to happen. It's going a shorter way, right? It's a shorter circuit. It's skipping the LEDs and it's going right through the Play-Doh to Play-Doh, and it's not lighting my lights. So that's kind of why that happens. And then of course, again, a good property of a parallel circuit is, again, if I pull these out, it doesn't, like the additional light that's still there, it still lights. Okay. I'm back to my smaller balls of Play-Doh and just my single LED. I really do want to keep these things like pulled apart. I think there's even maybe an issue, I'm not sure, of the electrons jumping across. I do get a brighter light when I keep these nice and spread out, because again, if I push this together, that electricity is going to take the shortest path through that Play-Doh. It's not going to go, it's going to take that shortest path. It's not going to go through the LED when I spread them out. So it might be nice though, right? Like as I'm making this, it's kind of annoying, like those things can accidentally bump into one another. If I put some kind of insulating material in between there, and you know, if you saw the other video, like a possible sequence could be the day before this, with students, we did a bunch of tests to determine what kinds of materials are conductors and what kinds are insulators with an inquiry process. So here, we know that rubber is an insulator. So we had this old placemat. I mean, my kids are getting older now. I mean, maybe if people visit, we could have used this thing, but my wife is at home and isn't really here to stop me, and so I've been cutting it up to get insulating material. So don't tell anybody. All right. So, but just looking at this, I mean, I think my point though, and like why I'm showing you this is like because you probably do have like household stuff where your students do that you know, you can ransack for this, and this is a good example. You know, we're not doing anything with this placemat. It's kind of like gross and creepy, and we don't have a baby in the house anymore, and like the kids are getting older. So this might be tough because this will be mangled if we have a baby visiting, but hey. Earlier, right, this is not going to light up the LED because I have a short circuit and that Play-Doh is touching. Well, what happens if I stick that insulator, that piece from that placemat, in there? So I'm going to take this piece of placemat and I'm going to stick it in between here, and now it should light up, although no. Okay, so again, why not? So it's always good as far as like debugging goes. We want to make sure our connectors, are those looking okay as far as back to the battery goes, because these are both plugged in, right? All right, and I have my insulator in there. That's maybe a little bit better view. So according to my theory, this should be working, but I look back at my battery and I see my connector slipped out, and so I'm going to go ahead and plug that in, and now I have that lit. And so we see, like, with that insulator in there between these two pieces of conductive material, that LED lights up fine. The electrons can't get across that insulating material, and so now my LED lights. But if I take this away, and if that means those are touching, right, it's not going to work anymore. Okay. All right. Awesome. Good. I had to set up a series circuit with this. So my always like popular example of this is like a string of Christmas tree lights, or at least the old school kind, so that when one Christmas tree light was burnt out, they all didn't work. So what I'm going to do here is like connect all these by LEDs. I have my positive like going this way, right? And then my current is going to flow across here and then here as I connect them. So I just need to make sure that I have my LEDs like pointed the right way. And I think you can kind of see that, you're not going to have any light here unless like all of these are connected, because it's going to jump. It's going to go through this whole thing. And that did not work. But for my debugging on this, I tried to just make sure for sure that I was going in the right direction, like positive to negative, positive to negative. So why didn't it light? And then I removed one of the LEDs. Maybe there's just not enough power to power this whole thing with resistance from the Play-Doh. And so here, I don't know if you can see that, but so we are getting some light in there through both of those. But it's pretty dim. So, but it is working. Okay, and I'm going to remove now this piece of Play-Doh here, and I think then we should see better performance. Hold on. Piece of Play-Doh there is just gone. Now I've just got two pieces of metal touching there, and this should be a little brighter. And I think it is. It's a little awkward to get these to touch. Okay, but okay, that does work. Now I think this is like getting knocked out. And I don't know if you can see it is lighting up. Okay, good. All right, and then we're back to where we have a much brighter light when we have kind of less Play-Doh, fewer LEDs, right? And one thing we could do with students is we could talk about the concept of resistance, right? If I have more either not a strong conductor and more material like just to go through, like right in general, we're gonna have a less bright of a light. And there I have nothing. Oh, right. So actually, this is a good example of like why this doesn't work right, because what's going to happen is my electricity is going to flow like just through this green here, right? It's going to totally bypass the LED because it's going to take the best path. In addition to that, my power cord came out, so that's another reason. Okay, but it's not too surprising that this doesn't work. This also came out. Oh my god, everything's falling apart. It's not too surprising that this doesn't work. We need to have this go through a break. So, and we could do that, like if I pull this out, my time on this video is ending. Okay, we should get something there if this thing is hooked up right, which it isn't. Okay, there you go. So that does work. Actually, that's still pretty bright, even with a pretty long piece of Play-Doh. But I think you can see, depending on where your students are, like even really young kids could be super engaged by this. And we got a lot of key concepts out there in a super friendly way. And these materials are really easy to work with. I think they're easier to work with than, say, the tin foil that I worked with earlier. And so, thumbs up to the squishy circuits, and signing off.